The distance formula shows up somewhat more commonly than midpoint. Not a huge topic, half a test or so. It's a good point to get. The problem is nobody can ever seem to remember the distance formula. It's this. Distance equals square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. That's not a lot of fun to remember. Good news is you don't have to. You already know this formula, but you just don't know that you know this formula. I don't know why they don't teach it to you this way, because it'd be way easier. Whoop, sorry, big noise. But there's a much simpler way to think about all this. They described a diagram in the question. I'm going to go ahead and draw it. 4, 3, 1, 2, 3, 4, 1, 2, 3, and negative 5, 1, 2, 3, 4, 5, negative 3. So in that distance formula, you saw that we subtracted the two x coordinates, right? And then squared it. Okay. What that does is that basically, well, ignoring the square part, but subtracting the two x distances basically finds us this. Subtracting the two y distances finds us this. Guess what? X and y are perpendicular. Always. Whenever I deal with distance and length is what I'm really talking about. Length and distance, same thing. In 2 dimensions, I'm talking about x and y. How much of this direction, of whatever way I'm going, paint the fence. Sorry, old joke. How much of the direction I'm going is an x component, how much of it is y. That's how we measure distance. And guess what? It's just the hypotenuse of a right triangle. How do we find the length of the hypotenuse of a right triangle? Pythagorean theorem. Review that if you need to. A squared plus b squared equals c squared. The only difference between the distance formula and finding distance and the Pythagorean theorem is that in the Pythagorean theorem, if I'm just giving you a right triangle and I say, well, this is 3 and this is 4 and then this is whatever, 5, then I tell you how long these sides are. With the distance formula, we actually have to find how long these sides are by subtracting them. So I go from 4 to negative 5. So 4 minus negative 5 is 9. And to be honest with you, you could do it the other way around to get negative 9. It won't matter because you're going to square it. 3 and negative 3, so 3 minus negative 3 is 6. Again, it could be negative 6. It won't matter because I'm going to square it. So now I have a squared is 9. 9 squared plus 6 squared equals c squared equals distance squared. And let's do the math. 81 plus 36 equals c squared. And 81 plus 36 is 117. Thought so. This would be the square root of 117. Now, your calculator may simplify that for you, and try to set up your calculator to simplify roots like this. There are ways to do it. Google it. But if you know your multiplication rules, your multiplicity rules, you would see that 1 plus 1 plus 7 is 9. Anything that adds up to a multiple of 9 is divisible by 9. 1 plus 1 plus 7 is 9. Therefore, 117 is divisible by 9. If I divide that by 9, I get 13. Now, 13 is prime. So I can't do anything now, but I can pull 3 out, right? Because the square root of 9 is 3. And I can say it's 3 square root of 13. That's all I can do. That's how far it is apart. Ta-da. Not too bad, right? Just remember Pythagorean theorem. Pythagorean theorem rules here. That's what this is. And that's what the circle formula is too. The one that everybody has a hard time remembering. Check that video out if you'd like. As far as the root stuff goes, try to set your calculator up for this. But if you can't, we'll just look and see what it divides into. If a number adds up to a multiple of 3, it's divisible by 3. If it adds up to a multiple of 9, it's divisible by 9. Those are the two that I think are most useful. And you simplify this the best you can. If you really were stuck, you could resolve this into a decimal and then test answer choices that look like they were close, right? So obviously 1 is root of 106, 3 are out. So you would just have to test D and E if you were having trouble resolving your roots.